Hello everyone, welcome to the next topic of today's lecture, which is about S format instructions. So we talked about how we can load data from memory when I discussed I-type instructions, but now we need a method to store data to memory. So S format is used for store instructions. So a store instruction needs two registers, RS1 for its base address and RS2 for its data to be stored. It also can be very useful to have an immediate offset. It's not necessarily needed as we can store the full address already in a register, but if we have extra bits, let's add it. It will just reduce the number of instructions we have to execute to do a normal store. So we can't really have both RS2 and the immediate field as we had in an I-type instruction because they're in the same place, which means that we need to either have a smaller immediate or move the immediate around in some way. But you might have noticed when I was talking about what we need for the store instruction, I never mentioned we needed RD, which means we now have 5 bits that we can use for whatever. So why don't we just move the lower 5 bits that we lost to RS2 and put that into the RD location? I mean, this sounds like a radical idea, like why don't we just move those registers down? I mean, that would make sense, right, for like thinking about this. But the thing is we care much more about hardware and the simplicity of hardware. And in this case, if we keep all the registers in the same location, this allows for us to actually read the data from registers at the same time as we're decoding the instruction. We don't need to worry about figuring out what instruction we want to do, and then figuring out, okay, we need to get these bits so we can actually read the registers. We can do this at the exact same time, which is very beneficial to us. And finally, I have given you an example, I've given you the format down below here of how we actually do an S-type instruction. First, we have our opcode, which is in the exact same place. It's 7 bits, just like all the other types I've discussed. Then we have func3, rs1, and rs2. These are in the exact same locations as they've always been. You'll notice now that we have im 0 through 4, which is 5 bits for the immediate, which is the lower 5 bits for immediate. This is where RD used to be, but we don't need RD in a store instruction, so we're actually going to be using these bits for our immediate. And finally, we have the 7 bits, which was the func7 in an R-type instruction. We're going to use this as the upper 7 bits of our immediate. So let's now translate this store word instruction. So we have our instruction here. So the first step, like always, is we need to figure out the instruction type, or we need to figure out the type of instruction that we have. Store word, I mean, that's kind of easy. It's an S-type instruction, but if you didn't know this, you can just look at the green sheet under the format column and you'll be able to see what it is. The next step is to figure out, once you've gotten the format field, then you need to look at the opcode and func3 of this and pull those off of the green sheet. So you can just find those on the green sheet and then just pull those out of there. Then we want to pull in RS1 and RS2. I want to point out RS1 is this value right here and RS2 is this value right here. It's not the reverse. And you might be wondering, why is this the case? Well, this is actually due to how the data path is designed in our hardware. We'll actually get into how this is designed in a future lecture. And finally, we have our offset or immediate, which is 8 right here. So the first step to actually translate our offset is to actually translate it into the 12-bit offset that it would normally be. Once we have those 12 bits, we can just slice it right where the 5 and 7 bits are and just fill those into the corresponding locations. For example, you can see 8 is just 1000, which means the lower 5 bits are just 01000, and we can just put those here, and then the upper bits we can just put right here. So it's really nice, and it makes it really easy to reuse a lot of the hardware that we have. Finally, here are the different store instructions that RISC 532-bit supports. I just want to point out that there isn't like a store byte unsigned or a store half unsigned, because once again, this doesn't actually make sense when we're storing to memory. Because you can think of memory as an array of bytes, and so there isn't any reason to actually sign extend, because it's not like we're trying to fill a specific amount of data. In this case, we're just trying to fill in the specific data that we've specified by each of these instructions.